when you look at these types of problems that have inequalities, and there's some sort of function on the left, really the goal should always be to find intervals that are true. In other words, they satisfy, these set of numbers will satisfy this condition that those numbers, when you plug them in, will be greater than or equal to 0. So it doesn't matter whether they have a fraction or if it's just a function like this on the right. The process is the same, right? So I believe step one is set the numerator and denominator equal to 0, and then factor, or in other words, solve for x. So on the left, we have x minus 5 equals 0, 2x plus 3 equals 0, and x minus 1 equals 0. Now, you could also write it as x minus 1 squared equals 0, but the squared part really is whether your true or false is going to bounce back at that value. So on the right, well, we'll do the one on the right separately here. Before we continue to do a number line, you have to solve for each x, right? You don't necessarily need to move the number, and have x equal something. You could already solve for it. So the first one is x equals 5. Why? Because 5 minus 5 equals 0. In this case, if you do the math, I'll leave that to you. But if you do the math, x should equal negative 3 over 2. Okay? Now, you could use a calculator, but try to do a little bit of math. But this is basically negative 1.5, right? The goal here is for you to understand that it's a little bit above negative 1, right? Or a little bit to the left of negative 1. The last one, yes, you have to really imagine the fact that there is x minus 1 times x minus 1. However, the answer is still the same. It's going to be equal to 1. It just has multiplicity 2. So at this value, it doesn't cross and switch sign, meaning it doesn't go from f to true. It bounces, right? And we'll see that right now play out. But once you set the numerator denominator equal to 0, you solve for the x's. The most important part comes here into play, because this is setting yourself up to get the actual interval. So we put the numbers on this number line. So we'll have 1, negative, well, that's negative 5, and then negative 1.5. Okay, and I'm imagining right now where 0 is at. And because I didn't put 0 on the number line, I could use that as a test point. But before we get there, always try to, at least in the back of your mind, understand whether these are open or closed. Now, in a nutshell, this is one of the most common questions that was asked was, well, how do I know if it's open or closed? Well, in this case, we need to see the denominator and know that that's different than the numerator, okay? In other words, anytime you have a denominator, it's always going to be open, right? And if you think about it for a second, we've always repeated that you cannot have the denominator equal 0. So if you plug in negative 1.5 here and 1 here, they'll equal 0. You can't have that. So as a result, you have negative 1.5 and you have 1 open. Now, the last one, we really have to look at that. That's greater than or equal. Therefore, anything that's in the numerator, right? And by the way, all of this right here on the right, this is all a numerator because it's all over 1. Anything in the numerator is closed if it has the greater than, less than, but more importantly, the equal part, right? So there you go. Now, it comes down to the last part here is the test point, right? We can do test point 0, something that was notoriously happening in class. People would do this. It was like 50-50. Some people would understand that this wasn't an actual value on the number line, but some people would literally put false and then true over here, and that is where it kills you. So my recommendation is have it a little separate. Don't get carried away, and take your time and be able to check your work after. So once we plug in 0, we're going to find out whether that's true or not. So I'm going to do some imaginary work right here. So if I plug in 0 here, 0 here, and then 0 here, on the top I'm left with negative 5 divided by, and in the bottom we're going to have 3 times negative 1. 3 times negative 1 squared. Don't forget the squared part. So really this right here becomes positive. So we have 3 times 1. So that's going to be 3. So negative 5 over 3, that's going to be negative number. And that's the most important part, that it's negative. Now you ask yourself, is negative greater than or equal to 0? No. So that ends up being false right here. False. Okay? Now you need to imagine, as you're now crossing, right, there's some graph happening here. And as you're crossing negative, or as you're approaching negative 1.5, approaching, is it going to cross? Well, look at the multiplicity here. It's 1, it's odd, therefore it does cross, therefore the sign switches to true. Now let's go to approach 1. And we got to look at the 0 right here up here. So where did we get that from? We got it from here. What's the multiplicity? 2. Therefore, it's going to bounce and it's going to stay F, right? So this sign wanted to cross and turn true, but because it's even multiplicity, it bounced and stayed false. So with that being said, the last one was 5. And if you look up here, 5 has a multiplicity of 1. So it crosses, so true. Okay. Now you do this for you to have a visual of the answer. Remember, this is not the answer, but if you get here, you got super far, but you need to close it off, right? You need to close it out and write an answer. So really all you care about are the truths, and you read from left to right. So you set it up like this. Okay, it's going to go from negative infinity to true, and this true is a parentheses here, and then it's going to be F and F, so that's a big fat union right there. And then it's going to start back up at this other true. And I see that it's a closed circle. So that's bracket 5, comma, infinity. Infinity has always been and will always stay parentheses. So I want to go ahead and close it. And literally, you already wrote the answer, but please do it formally, yeah? And that is going to be negative infinity to negative 1.5 union bracket 5 to infinity. I would suggest you pause the video and attempt the other one out, right? It is a little different, but really it's the factoring that's different. So if you recall, anytime, the trick here is this, okay? If you see two x's right here, you're going to need to factor out an x. There is no other way. So if you see two terms and they both have x's, factor as many x's possible out. How do you know how many you can factor? Look at the lowest power, the lowest exponent. That's how many you can factor out. Now, the other thing you want to pay respect to is the number, okay? Usually when it's like this number should be a perfect square. And if that's happening, then you'll see what's going to happen with the math. So let's go ahead and just kill this one, okay? So x squared factored. When you factor something out, you should always start like this. So then the next term, x squared times what gives me what I had, x to the fourth. Well, I'm missing x squared minus x squared times what gives me what I had. Well, that's just 16, okay? Now at this point, you don't really want to set it equal to or put less than 0 anymore. You really want to set it equal to 0 because you need to solve for the x's. That's the first goal. So here we have x squared equals 0, or, right, this other one, which is x squared minus 16 equals 0, okay? On the left, this is, again, telling you all it means is that you have a multiplicity of 2, right? But really, you ask yourself the same question. What squared is going to give me 0? Well, it has to be 0. There's no other number. So x equals 0. But again, remember, that's multiplicity 2. So in the back of your mind, you should already have the word bounce, touch bounce. And then this other one, there's multiple ways to do it, right? Think about it. What squared will give me minus 16? Otherwise, you need to add 16 to this side and then square root both sides. If you do it that way, great. But I always like to keep it simple. What value squared is going to give me minus 16 equals 0? That's 4 and negative 4, right? But be careful. This doesn't mean that there's a multiplicity of 2. Remember, this just told me that there's two answers, 4 and negative 4. Had these both been 4, that would have been a multiplicity of 2, but they're not. It's 4 and negative 4. So in fact, they're two separate answers. So now same thing. Let's speed through this. Number line, go ahead and drop the zeros. So 0, 4, and negative 4. Here you should immediately find out that you cannot plug in 0 as a test point. Why? Because it was an actual value. But again, remember, what I'm thinking already in my mind is because it's 0, I'm either going to have true, true here or false, false here because of this multiplicity. Okay, so let's kill it real quick. Again, this is already taking quite a bit. So in this case, I'm just going to do test point 1. I like to hover between test point 0, test point 1, test point 0, test point 1. If you like to pick a bigger number or smaller number, hey, it's you doing the math. So let's plug it in. 1 to the 4th power. I already know that's 1, right? 1 to anything is 1. And then minus 16, 1 to the 2nd power. That's going to equal 1 minus, again, 1 squared is positive 1. So that's just 1 minus 16. Okay, check the math if you're a little iffy about it. But it's 1 minus 16. And therefore, that's negative 15. All right. Therefore, it's negative. All right. Negative 15. So is negative or negative 15 less than 0? You see how the number never really matters, but negative is less than 0, so that's true. So when I had my test point at 1, that was true. Again, in the back of my mind, I have not forgot that because of the multiplicity of 0 being 2, it bounces, right? So then I look at my 4, that's multiplicity 1. I look at my negative 4, that's multiplicity 1. Remember that I got that from here. If you do not picture that, remember that breaks down to 2. X minus 4. X plus, dang it, sorry, I went out of the page there. It's x minus 4, x plus 4, okay? So, again, we're already done. So it's going to cross that negative 4 and 4, so that's false and that's false. Because it crossed and the thing next to it was true, therefore it becomes negative. So literally our answer is right there. But one thing I did skip, right? Because I'm looking at this, I'm thinking about it, I just forgot the little open or closed. But again, as long as you pick it up for yourself, you're good. This does not contain less than or equal to. It's just less than, therefore they're all open. I didn't have to think about that much, and you shouldn't either. So my interval's from right here, or let's be more specific, it's from right there to right there. So that's negative 4 to 4. So that's the answer for, whoops. That's the answer for that, and that's the answer for that there. So this is this type of video. If you want to try it out, go for it. Remember, all you have to do is change a number, and now you have a different problem. But go back to the review and try some different problems out, right? Some of those have solutions.